Video we will discuss all pairs shortest path problem using the Floyd Warshall algorithm. So this algorithm uses the dynamic programming design technique. So we have already learned the single source shortest path problem. Single source shortest path problem means it uses a single source. For example, in this case, the source can be one single source. So here we can consider the source as the node 1. So from 1 to all the remaining other vertices 1 to 2, 1 to 3, 1 to 4, 1 to so total 4 vertices, so 1 till 1 to 4. So this is from single source to all the other vertices. So for this one we have learned an example which is the Dijistra's algorithm. We have seen the Dijistra's algorithm for this. Then now we can see the Floyd-Warshall algorithm which is used to find the shortest distance or minimum distance between any pair of vertices. For example, 1 to 2 is a pair of vertices, then 2 to 3, 3 to 4. So any pair of vertices. So that is the all pairs shortest path problem. So it will give the minimum distance between all the pair of vertices in the graph. So this can be obtained by doing this Dijistra's algorithm for every node. And another approach is the dynamic programming approach. Dynamic programming approach, which uses this Floyd-Warshall algorithm. In dynamic programming approach, problem should be solved by taking sequence of decisions. So first, to find, we will draw the adjacency matrix for the given input graph. After that, for each pair of distances, we have to, for example, 1 to 2. The distance from 1 to 2, it is 8, it is 3 in the given graph. So for each pair of vertices, we will consider an intermediate node, and we'll find the distance through that node. If the distance through that node is less, then the current distance will be replaced by that distance. For example, 1 to 2, the distance is in the graph, the distance is 3. And if we consider an intermediate node, say for example 4, and 1 to 4 the distance is 1, and 4 to 2 the distance is 1, then the distance from 1 to 2 through 4, 1, 4, 2, this 4 is an intermediate node, so this distance is 2, which is lesser than the 1 to 2 direct distance. So we will replace the distance 1 to 2 with this distance, smaller distance. So in each step we will do the same procedure. So first we have to write the cost adjacency matrix of the given graph, the distance matrix. So it is represented by D0, and here I will write the cost adjacency matrix. So here there are 4 nodes. So these are the diagonal elements always will be 0. So here 4 nodes means 1, 2, 3, then 4. Here also 4 rows also will be there, 1, 2, 3, 4. So 1 to 1 the distance is 0. 1 to 2 the distance is 3. 1 to 3 there is no direct edge. So the distance is infinity. 1 to 4 the distance is 7. So this is written from the given graph. Then 2 to 1 the distance is 8. 2 to 2 again the distance is 0. 2 to 3 the distance is 2. 2 to 4 there is no direct edge, so the distance is infinity. Similarly we write the other distances 5, 8, 0, 1, 2, infinity, infinity, then 0. So this is the cost adjacency matrix. This gives the distances between each pair of vertices. Now we have to, in each step we have to consider the distance through an intermediate vertex. And if the distance through that intermediate vertex is lesser than the given distance, then the given distance will be replaced by the intermediate node distance. So here, first we will write the D1. So how we will write D1? For D1s, we will select the intermediate vertex as node 1. Intermediate vertex 1. So it is named as D1. So we will consider the distance through 1. So if we consider the distance through 1, we will keep the first row and first column of the matrix as unchanged. So here we can write down 1, 2, 3, 4. This doing for the intermediate vertex is 1. So we will, this first row 0, 3, we will keep the same values 0, 3, infinity 7, and first column also we will keep the same set of values 0, 8, then 5, then 2. That remaining values we have to fill. So the remaining values means the what is the first value is D22, which means it is a diagonal element, so it is 0. Diagonal elements will be 0. The next element is D23. So we have to write D023. We have to compare whether the distance through vertex 1 is smaller. So D23, it is compared with, so intermediate vertex here we will consider the vertex 1 as the intermediate vertex. So through the intermediate vertex the distance is D0 from 2 to 1, then 1 to 3. So we will consider that distance 2 to 1 plus 1 to 3. D0 of 1 to 3. So among these values, whichever is greater, that we will keep as the value here. So D0, 2 to 3. What is D0, 2 to 3? D0 is this matrix. Second row, third column, the value is 2. And D0, 2, 2, 1. 2, 1, the value is 8 plus D13. 1, 3, the value is infinity. 8 plus infinity. So this value is lesser. So we will keep the previous value itself, 2. Now we have to find out the next element, that is D24. So we have to do the same procedure for D24. So D24, D024, consider the, so this part we are doing for the vertex intermediate, considering the intermediate vertex as 1. So we have to, in this step we will be considering the intermediate vertex as 1. So 2 to 1, 2 to the intermediate vertex, then from 1 to 4 plus D0, 1 to 4. So the values here we will obtain it as 2 to 4, it is infinity. Then D0, 2 to 1, second row first one, the value is 8 plus D0, 1 to 4, the value is 7. So this is 8 plus 7, which is 15. So we will, 15 is lesser than the infinity value. So we will replace this infinity value here with 15. Now next is this one. We have to find D. Next question is D 3 2. 3 2. D32 is compared again considering the intermediate vertex as 1. Then D31 plus 3 to 1. Then from 1 to 2. D0 of 1 to 2. So these values D0, 3, 2, it is infinity. And here 3, 1, it is 5. And 1, 2, it is 3. So 5 plus 3, 8, which is lesser than the infinity. So we will replace the infinity value of this with the value 8. value 8. Now we have to find for this. This is we need not find this a diagonal element, so it is 0. Next is D 3 4. So that I will write here. D 0 3 4 will be compared with D 0 of 3 1 plus D 0 1 4. So writing down the values here. D 0 3 4 it is 1. Then it should be D031 it is 5, then 1 4 it is 7. So here 1 is lesser, so we will keep the value 1 itself. Then next we have to, then next is this element D42. So D042. D042 will be compared with D041 plus D0 of 1 2. D042 which is infinity is compared with D041 it is 2 plus D012 it is 3. So infinity will be greater, so we'll replace this infinity with 5. Then next is 4 3. D043. So D043 that will be compared with D041 plus D013. D041 plus D013. So this is D043 it is infinity, D041 it is 2 plus D013 which is infinity. So we will keep the same value, infinity value. So infinity, both are infinity. So we will keep the infinity value here. Then this is 4 4, D04 again diagonal element, so the value will be 0. So this is how we will obtain the distances D1. So D1 means we are finding out the distances between each pair of vertices by considering vertex 1 as the intermediate vertex. So now we can see the next step. One step is over. Now we will select. So in the first step we have selected the intermediate vertex as 1. So in the next step we will select the intermediate vertex as 2. So one by one we will take the intermediate vertex as 2. So when considering the intermediate vertex as 2, so we will write this distance as D2. So this 1 we will write not here, but as a superscript we will write. So here also D2. So D2 is the distance between each pair of vertices by considering the intermediate vertex as 2. So here again we will draw the post matrix. So we are doing for in considering the intermediate vertex as 2. So we have to keep the second row and second column unchanged. These are the columns 1, 2, 3, 4. These are the rows 1, 2, 3, 4. So we will write the second row. We will keep the previous value for the second row and second column since we are doing for the second vertex. We are considering the second vertex as the intermediate vertex. So second row it is 8 0 2 50. So that I will keep it here 8 0 which is 8 0 2 and 50. Then second column is 3085. 3 here, 0 here, 8, 5. Remaining distances we have to find. Here again, what is this distance is diagonal element, so I can put 0. Now this one I have to find, so that is D13. So the values distances will be compared from the previous vertex. D1 of this is 1 3. 1 3. So here the intermediate vertex is 2. So we have to find the distance from this node to 1 to 2 plus 2 to 3. So here it is. We'll compare this with D1. 1 intermediate vertex is 2. So between 1 and 3 we have to keep the 2 intermediate as intermediate vertex. 1 to 2 plus D1, 2 to 3. D1, 2 to 3. So here the values are 1 to 3. The value is previous. We can check the D1. D1, 1 to 3. The value is 1 to 3. The value is here infinity. So infinity. So infinity will be compared with D1, 1 to 2, it is 3 plus D2 to 3, it is 2. So it is 5. So 5, we will write the value 5 here. So infinity, 5 is lesser than this infinity value. Now we have to find for the next element, which is D1 to 4. So 1 to 4, this will be compared with D, what is the intermediate vertex? 2 itself. So 1 to 2 plus D 2 to 4. 1 to 2 plus 2 to 4. So here D1 to 4 it is 7. D1 to 2 it is 3 plus D2 to 4 it is 15. So here 7 is lesser. So we can keep the previous value 7 itself. Then now this row is for second row we need not, we will keep the same value itself. Then now we have to write for D31. So here it is D31. So D31 will be compared with D, consider the intermediate vertex is 2. So D32 plus D21. D32 plus D21. So D31 it is 5. D32 it is 8. Plus again D21 is 8. So this 5 itself is lesser. So we will keep the previous value 5 itself. Then next we have to this D33. This is a diagonal element. We can keep it as 0. Next is D34. That we can write here D34. D34 is compared with D, intermediate vertex is 2. So D32 plus D24 plus D24. So here D34 the value is 1. D32 it is 8 and D24 it is 50. So 1 is lesser, so we can keep 1 itself. Then now we have to find out D41. So D41. So D41 that will be compared with D42 plus D21, which is D41 is 2, D42 it is 5 plus this is D21 it is 8. So this value is lesser, so we will keep this value 2. Then next is here D43. D43. D43 is compared with D42 plus D23. So here D43 the value is infinity, D42 the value is 5 and D23 the value is 2. So the 7 is lesser than the infinity, so here we will keep the value 7. Again this is a diagonal element, so we will keep the value 0. So D2 matrix is completed. So next we will continue with the same procedure. For now select, so this is our previous matrix now D2. Now select the intermediate vertex as 2. Sorry, 3. Intermediate vertex 2 is over. Now we will consider the intermediate vertex as 3. Then we will repeat the same procedure. So we will get D3. So here we have to make the third row and third column as fixed. So third row we will write the, so these are the 1, 2, 3 and 4, and here also 1, 2, 3, 4. So here we will keep the third row as same. So third row here it is 5801. So 5801. Then third column it is 5207. 5207. Then we have to find out diagonal elements will be zeros, and now we have to find out the same elements, the remaining elements using the same method. So here first we will continue like this. So here it is D12. So D, so here we had to consider the just previous matrix, which is the D2. D2 of this element first we had to find out D2 of 1, 2, which will be compared with. So here the intermediate node is 3. So the distance through 3 we have to find out. So D2 1 to 2 is D2 1 is combined with D2 1 to 3 plus 3 to 2. So here this is 3. This is 5 plus 8. So this will be compared. So 3 itself is lesser. So we will replace it with 3. So we will keep the same value as 3. This is lesser. So we will continue in this way and we will fill all the values. So D3, the remaining values we will get as here we will get 6, then 7, then 0, then next is 3 here, then 4, 1 it is 2, 5, then here it is 0. So we can complete this, the remaining values. And then after 3 again next is the, and you can check whether the answer is correct. And now we have 3, vertex 3 is over. Now in the next step what we have to select is select the intermediate vertex, select the intermediate vertex as 4. So here again this fourth row and fourth column. So now we will be writing. So D3 is over. Now we have to write the D4. So for D4, we'll consider the intermediate vertex as a fourth vertex. So fourth row and fourth column remains unchanged. So 1, 2, 3, 4. Here also 1, 2, 3 and 4. So what is fourth row? It is 2570. 2570. So that will be kept as 8, 2, 5, 7 and 0. Then fourth column it is 6310. 6310. All the remaining elements, diagonal elements will be zeros. The remaining elements we need to find out. So D, first we will find out D. The same method we will do the procedure in the same way. D1 to 2, which means here now we are considering intermediate vertex is 4. So we have to find the distance from through 4. So D1 to 4 plus D4 to 2. D1 to 4 plus D4 to 2. So that distance will be D1 to 2. The distance is, so here it is, we'll referring the next just above just previous matrix, that is D3. So D1 to 2 it is 1 to 2 it is 3. D1 to 4 it is 6. Then D4 to 2 it is 5. So this is lesser. So we'll keep this values. Similarly, we can fill the other values, all the other values. So after that we will get the values as, here we will get 5, then here it is 5, then here you will get 2, and here you will get 3, then 6. So these are the values. So this D4 is the, gives the shortest path, gives the shortest path between all pair of vertices, between all pair of vertices. That means this is all pairs shortest path problem we have solved using Floyd Warshall algorithm. Now we can see the algorithm for the Floyd Warshall method. find the all pairs shortest path problem. All pairs shortest path algorithm is also known as Floyd Warshall algorithm. It's used to find the shortest path between all pairs of vertices. All pairs means if have four vertices, 1, 2, 3, 4, then it will give the shortest path between 1 to 2, 1 to 3, 1 to 4, then 2 to 3, 2 to 4, then 3 to 4, all pair of vertices. Negative edges are allowed here. In Dijistra's algorithm, it will not allow the negative edges. But here, this Floyd-Warshall algorithm allows negative weight edges. As a result of this algorithm, it will generate a matrix which will represent the minimum distance from any node to all other nodes in the graph. Floyd-Warshall algorithm is an example of dynamic programming approach. Dynamic programming approach means it will check all the possibilities and selects the best one. So here we can see the algorithm. Let V be the number of vertices in the graph, total number of vertices in the graph, and this DIST, this is the distance matrix, array of minimum distances. Initially, we will make all the elements as 0. Then for if there is an edge, direct edge, we will keep the weight of that edge or cost of the edge in this matrix. Then we have to compare the current I to j distance. If I to j there is a path or there is an edge, it is compared with the distance through an intermediate node, for example k. I to k, then k to j. So whichever is lesser, we have to compare. So distance I to j means this is the I to j distance, current distance. It is compared with distance through an intermediate, that is k, and k value changes from 1 to b, all the vertices. We will consider as the intermediate vertices. So I to k plus distance k to j, k to j, this distance. So if this is lesser than distance of ij, that is replaced by the lesser value or the minimum value, and this is getting repeated. So now we can see the analysis part. In analysis, we can directly say since there are four loops, then the analysis, the complexity value is big of n cube.